So here we are going to calculate the value of acceleration due to gravity at this place. So for this we are using simple pendulum. This is a simple pendulum. It consists of a metallic bow and it is suspended from this stand using a thread. First we want to find the diameter of this. So I am taking this and I am drawing a line here. I am placing two blocks. Two blocks are kept here and I am placing the bob carefully in between them. So I kept it here. The distance between the blocks can be measured now. See this distance, the gap is calculated. So it is 1.8. 1.8. So 1.8 is the 1.8 centimeter is the diameter of this bob. So I am noting the value. Diameter of the bob is 1.8 centimeter. So radius of this bob will be 0.9 centimeter. First, let me tell you about the length of pendulum. The length of pendulum means this is our pendulum. This is a point from where it is suspended. Length of pendulum is the distance between this point of suspension and the center of bob. So this length is the length of the pendulum. Suppose I want to suspend the pendulum at 20 centimeter. We know the radius is 0.9. So the distance between the point of suspension and the top of the bob must be 20 minus 0.9. That is 19.1 centimeter. So once again, this is a point of suspension. The length of pendulum means distance from this point of suspension to the center of the bob. I want to keep this 20 centimeter. The radius of the bob is 0.9. So the distance between point of suspension to the top of bob must be 20 minus 0.9. That is 19.1 centimeter. So I am going to do that. So I am taking the bob here. This is meter scale. I am placing like this. The top of the bob. The top of the bob is here. Then this is 19.1. Then I am marking there. Then I am suspending. Now the length of the pendulum is 20 centimeter. 20 centimeter pendulum. Now I am going to oscillate it. So let me tell you about the oscillations. See, oscillation must be of a small amplitude. So it must be so small. See, I want to calculate, find the time for 20 oscillation. One oscillation means, suppose I am starting here, 0, 1, this is one oscillation. So I am calculating the time taken for 20 oscillations. For that, I am using a stopwatch. So this is a stopwatch. There are two keys for it. So this is the stop and start key and this is reset key. So if you turn it on, so it will run. So you can off it, so it is stopped. If you want to reset, again reset. This way it can be operated. Now I am going to calculate the time for 20 oscillations. So starting the oscillations, then take the stopwatch. So when it reaches the left end, I will start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 19 seconds. I got the answer as 19 seconds. So trial number 1, length of the pendulum is 20 centimeter. Time for 20 oscillations is 19 seconds. I have to do this once again. So once again I can do this. So I will get a value very close to this. So suppose it is 19. Then I take the average of these two. So it is also 19. Then I calculate the time for one oscillation. It is t by 20. I calculate. So it is a value of t. Then I take the value of t square. Then I take the value of L by t square. But this must be in meter per second square. L must be converted to meter and t square is in second square. So the answer will be in meter per second square. In the next trial, the length must be made 40 centimeter and the experiment can be performed in a similar way. Then 5 trials should be taken. First length 20, 40, 60, 80 and 100. Then we take the mean value of L by t square. Then acceleration due to gravity can be calculated using the equation G is equal to 4 pi square into L by t square. 4 into 3.14 square into L by t square. Mean value of L by t square we have calculated already. So its value is substituted. So we get the value of G. So the value will be very close to 9.8. That much meter per second square. Then we are plotting a graph between L and t square. There you can find the graph. Here on the x-axis I am marking L, 20, 40, 60 like that I can mark the values. Then on the y-axis I am marking the values of t square. In the first case there will be a value of t square. So the t square values are plotted here. I get a straight line graph. So straight line graph indicates that L and t square are in direct proportion. Then from this graph also I can calculate the value of L by t square. So this is the graph. So I am taking suitable values. See this AB I am finding a triangle here. You can find a triangle here. So this side, the length of this side is L and the length of this side indicates t square. So if I take AB by BC, it will be the value of L by t square. So on putting the equation G is equal to 4 pi square into L by t square, you get the same value of acceleration due to gravity. That's all about the experiment. Hope you understood.